Okay, so in 6.5, we're going to talk about factoring strategies. So we learned all these different methods of factoring. What's the number one rule, the first strategy we're going to always use when it comes to factoring? We're going to look for a GCF. So the number one rule is factor out the GCF. So if you have something like 9x squared plus 3x, what would be the GCF here? 3x. So if we factor out 3x, what do we get? 3x plus 1, right? So that's the number one rule of factoring, is look for a GCF, factor it out. So that's what you're always going to look for. Step 2 is if it's a binomial, the only kind of binomials we factor, well here this was a binomial, so we already looked for the GCF. So notice that's fully factored. Do you notice that? So there's no more squared term. So for binomials, we're looking for difference of two squares, dots, which would be something like this, x squared minus 25. Can anyone tell me how that would factor? X plus 5, x minus 5. Okay, and then you could also have the perfect cubes. Sum difference of two cubes. And that would be something like this. X cubed minus 27 or x cubed plus 27. Okay, this would factor to x minus 3 times x squared. We had the formula that we talked about in one of the videos. I can't remember which one now. X squared plus 3x plus 9. Okay, and then this one would be same exact thing except for it's x plus 3, x squared minus 3x plus 9. So you see the only difference is where that negative sign lives. And if the negative is here, it's going in the first one. If this is positive, that first binomial is going to be positive. So that was a formula that we learned. The next thing would be trinomials. Trinomials. So we learned trial and error, and we learned the AC method. Okay, so for an example here, if I had x squared plus 9x plus 20, and you wanted to factor that, what would the factors be? And I didn't really mean to put that in parentheses. I was just getting parenthesis happy, but it doesn't hurt that it's in parentheses. Can anyone come up with x plus 5, x plus 4. Okay, because 4 plus 5 is 9, 4 times 5 is 20. And we looked at all, when we did that, I think that was like 6.3, we looked at all the different patterns of signs, when it's negative, when it's positive, and all of that. Okay, the AC method we use for problems where we had a leading coefficient that was not 1. So for example, 6x squared minus 5x minus 6. So let's just recap here the AC method. This was actually the very first problem that we learned in 6.4. So this was 6.4, this was 6.1. These were 6.2, and GCF was 6.1. So this is the sections you can go back to. Oops, I meant 6.3 here. Okay, so for AC method, who remembers how to factor this using the AC method? What do we do first to do the AC method? Negative 36 that has a sum of negative 5. Can you come up with two numbers that multiply to negative 36 and adds to negative 5? 9 and 4. Good. So that means we break up the middle. Now, actually, while we're talking about the AC method, we're really learning this factor by grouping. Minus 9x plus 4x minus 6. We broke up the middle, And then this part right here that I'm doing next is when you have a polynomial with 4 terms, we do factor by grouping. Okay? So we're grouping. What's the greatest common factor of the first two? 3x, 2x, 3. Good. What's the greatest common factor of the last two? Plus 2, 2x minus 3. Factor by grouping here. We have a greatest binomial factor. This was in 6.1, I think we learned. Factor by grouping. So what are your two? Yep, 3x plus 2. Now you'll always want to FOIL to check. And we learned about FOIL in chapter 5.5, or yeah, I think it was 5.5 or 5.4. All right, any questions about that? This is kind of like your checklist. So you're going to want to go through and then see. And then sometimes it can happen that you have something that continues to be factorable. So I'm going to give you an example of that. So let's say you had this. Okay, I have to do some math. 18x cubed minus, don't tell me, hold on, 50x, 50x. Can anyone tell me, what would I do with this problem first? Yes, number one rule of factoring, always look for a greatest common factor. What is the greatest common factor here? 2, and do they both share an x? 2x. So we're going to factor out 2x. So that means I'm dividing each one of these by 2x, right? I get 9x squared minus 25. Now, I wouldn't want to just stop there, especially if I see that I have an x squared left. What are you seeing? Can this factor 9x squared minus 25? This is a binomial. It's called difference of two squares. So how do we factor the difference of two squares? What times what gives you 9x squared? 3x. Minus 5 plus 5. Okay, and if you wanted to check that, you could FOIL that. You would get that. You could distribute the 2x back in, and you should get that original problem. So you're basically working your way backwards when you check. You're just like Hansel and Gretel, like, hey, if I follow my breadcrumb path back, do I get home again? Right? I just want to see, are they equal to each other? All right, so now what I'm going to ask you to do is, now that we've reviewed the basic rules of factoring, you're going to want to go through and try all of these problems on 6.5 to see if you can factor them. Work in groups, and we will go over the answers after.